Okay, right. Thank you, students. I welcome you again for the second part of this particular problem solving by simplex table. So the last simplex table is this. Now look at this, the basic variables here. What is a basic variable? How I have written this here? Okay, so here in this particular table, which of them in canonical form? Canonical form, we know that 0, 1, 0, 0, 0, 1, 1, 0, 0. These three variables are in canonical form. So that variable we have to write here 1, 0, 0. That is that we are writing here. And S1 is in canonical form. Straight to that S1 we are writing. And then S2 is in the canonical form, and that we are writing as S2. This is I am taking as equation number 1, and this is equation number 2, and this is equation number 3. Now next step is the test for optimality. Step 4. What is optimality? In the maximization problem, our problem here is maximization problem. Am I correct? So in the maximization problem, all the entries here in the Z row should be positive, because maximization problem comes. Suppose minimization comes, all should be positive. Here maximization problem, so all elements must be a positive. If negative elements comes here, then that will damage our object of maximization. Am I correct? So here we see that minus 3 elements coming here. This definitely damage our object, that it should be maximized. So our aim is to remove these elements from this particular row. This element from this particular row we have to remove. Okay, that means we are going to make it here 0. Okay, that is we are going to make to bring x2 in the canonical form. That's what our next aim. So the fusible condition here is optimum is not reached because of this negative number. Okay, so this negative number, most negative number is minus 3. That should we are going to make 0 there. So now this x2 will come in any one of the places here. So the incoming variable, we say this is the incoming variable. Okay, so here optimum not reached. Okay, optimum is not optimum, that is maximum. Optimum not reached. Why? Because of the negative number there. Okay, see here, there is a negative number here, therefore optimum is not reached, which implies the incoming variable, the incoming variable incoming variable is what? X2. Now to bring this x2 inside, we have to bring out any one of this variable as a basic variable. Now bring inside means as a basic variable. So here S1 or S2 should move out, or we should move out. For that, a minimum replacement ratio we have to find out. Okay, so the minimum replacement ratio, the given by the formula, minimum of Ci divided by Ci divided by Xi, the coefficient variable. Okay, that's what we have to understand. Ci divided by Xi, or Xi, and sometimes we call it as a Bi. Some people will say as a Bi. Now, what is the meaning here? This is a constant coefficient, semi-kite, and this is corresponding incoming variable coefficients. So this variable divided by this variable divided by this variable, and that's called replacement ratio. Among them, what is minimum? That's what we are interested in there. Okay, so divide this by this and divide how can I write? Divide this by this. So the negative we should not take into account there. That's what you have to. So 1 by 1, 4 by 1, which is the minimum replacement ratio, is 1 by 1. Therefore, 1 by 1 is a minimum replacement ratio. Okay. Now, the intersection of the incoming variable, and the outgoing variable. Minimum replacement ratio gives you the outgoing variable. So here S2 is outgoing variable. Sorry, 1 by 1, and sorry, that's a mistake there I have made there. I will correct it now. 1 by 1, 4 by 1 I have taken into consideration, but that is not the case. You have to replace that. That is not. Look at this. Now I will take the red ink again. Now see here, 1 by 1. Am I correct? So this is the outgoing variable. So intersection of this and this, we call it as pivot element. This is called pivot. This is called pivot element. This we have to make it 1. Suppose any other number comes here, like as 5, 6, 7, like that, we have to make it 1 here. Then afterwards we have to go further. So the pivot element is 1. So our job is very easy now. Now by using this pivot element, we have to use here 0 and we have to use here 0. By using this pivot element, we have to make here 0 and here 0. Okay, that is the next our steps that will come in the next simplex table. Okay, so that's what next simplex table. I repeat that the optimum not is y, because our aim here is maximization of z, But here negative number in the objective function definitely damage our aim that it is should be maximized. So we are finding out optimum is not reached. So now how to make it optimum? We can replace this minus 3 here, minus 2. Minus 3 is less than negative number than minus 2. So our aim is to replace this. To replace this or to make it 0. To make it 0 means we can make this a canonical form. We can make it here 0, we can make it here 0, here we can make 1. So that is our aim. To find out, this is incoming variable is x2. To find out the outgoing variable, we are finding out the minimum replacement formula. So minimum replacement formula we are using here. So minimum replacement formula is Ci by Bi. Ci is the constant variable and Bi is the corresponding incoming coefficients. We are dividing this constants by this one, which is the minimum, and that is what the outgoing variable. So here the minimum is 1 by 1, therefore outgoing variable is yes 1. Okay, now we have to find the pivot element. Pivot element means the intersection of the incoming variable and outgoing variable. The intersection of the incoming variable and the outgoing variable is this, that's called pivot element. Our aim is to make this pivot element 1 and this element 0, by using this particular row, equation number 2. By using the equation number 2, we have to make here 0 and here 0. That is our next aim. Okay. So, and that is what the next simplex table. Next simplex table is that one. So let us do that now. Okay. So step number 5. Step number 5 is what? The next simplex table. Okay, so simplex table. For what? For what simplex table? In order to make here 0, here 0. So we have to multiply this by 3, add with this, you will get 0 here. You multiply by 3, add with this, you will get 0. Multiply this by 3, add with 0. Multiply by 3, add with 0. Multiply 3, add with 0. Multiply by 3, add with 0. Okay, so that way you will get 0 here and here some other number. Now here also we have to make 0. So what we have to do? By using this row, we have to make it here 0. By using this row, we have to make it here 0. What we have to do? Multiply the equation number 2 or row 2 by minus 1. Then add with this. You will get here 0. Multiply by 1, add with 0. Multiply by 1, add with this. You will get 2. Multiply this by minus 1, add with this. You will get minus 1. Multiply this by minus 1, add with this. You will get 1. Multiply this by minus 1, add with 0. Multiply this by minus 1, add with here 3 you will get. And that is what next simplex table. Now in the place of S2, x2 will come there because that will be in canonical form. So I will show this in the third part of my video in this regard. So go for next slides. Okay, part 3 of the simplex table by DrJ. So thank you.